Now, in addition to finding when a function is increasing or decreasing, the derivative can actually tell us when we hit a minimum or a maximum. And it comes from our critical point. So notice in this graph, I'm increasing and then I start decreasing. So in between there, since this is a continuous function, I'm going to have to hit a maximum. And that place is where I have a horizontal tangent line, which means the slope is 0. In other words, the derivative is 0 at that point. And what do we mean by that? Or what kind of point satisfies that criterion? A critical point. So the point is, the critical points can help you find your min and max. And this is what we mean by the first derivative test. And so the first derivative test says that a derivative goes from negative to positive once it passes a certain point. That point is either a local min or a max. Let's see, if it goes from negative to positive, that means it went down and then up. That critical point finds you a local min, a local minimum. If your derivative is increasing and then decreasing, that critical point we found is a local maximum. And this is what we mean by applying that is what we call the first derivative test. And I'll show you an example of that as well. Okay, now that we've done all this work, we can easily apply the first derivative test, which says that if a derivative changes from positive to negative at a critical point, that guy has to be an absolute max. And if it goes from negative to positive about a critical point, then that critical point is an absolute min. So since I've already done my sign chart here, I can see, look, I'm going from positive to negative here, I'm going up and then down. This guy at -1 is a max, so I have a local maximum at x equals 1, and you could say which is, x equals -1, which is f of -1, and I've already done this arithmetic. F of -1 is 6. So here I have a local max at the point -1, 6. Alright, I get that from the first derivative test. The first derivative test also tells me that I have a local min, or minimum, at x equals 1/2, which is the value f of 1/2, which I know to be -3/4. So you have a local min by the first derivative test at 1/2, -3/4. I hope this makes sense. Analyzing when a function is increasing or decreasing has a lot of application, as you'll find out in calculus. If you have any questions, please let me know. I'll be glad to help. Thanks for watching.